Okay, in this topic we'll be looking at this problem here, where we will be given 3 points on a flat surface or flat plane or on the horizontal. Whatever way, it is a flat surface like your table. 3 points. All right, they say consider points A, B and C are points on a level horizontal plane. However, sometimes they may not use the word level, they may just use horizontal plane, and that means it is still level. All right, the point B is 10 kilometers away from A and on a bearing of 30 degrees. Right, so B is from A on a 30 degrees and B is 10 kilometers away from A. From A, another point C is on a bearing from A at 140 bearing degrees, and BC are 20 kilometers apart from each other. So the first thing to do in this type of problem is to draw a diagram of what you have been given. First, you draw a rough sketch. Let me just fold this in half so we can work with this, and then we bring our page right here. Okay, and as we go along, we start to draw a rough sketch. There are considered 3 points A, B and C, so we know definitely that we're talking of 3 points on a level flat surface. So let me see, on a level horizontal plane. Point B is 10 kilometers away from A and on a bearing of 30 degrees. So we just draw roughly, as it's not a scale drawing, so you always start from the north. Come down this way, you put your angle, your north initial there. This is point A, and they told you that point B is 10 kilometers away from A, so B is anywhere around here. But because they're telling you that B is on a bearing of 30 degrees, you will start measure 30 degrees from the north coming clockwise. So when you measure that, you're going to get somewhere around here, and so you are going to draw a line and then write B right there. Okay, so you have B now, and you put here 0, 3, 0, which is the degree bearing of B from A. Now this is also 10 kilometers. Okay, let me use a different color pen for numbers and writing. Now apart from that, they're telling you that away from A and on a bearing of 30. Another point C is on a bearing of from A of 140. So there's a point C somewhere around, and that point is 140 degrees bearing from A. So from A, you're going to take and measure 140 degrees. So when you measure 140 degrees, you're going to be somewhere around here, and so you're going to draw a line in that direction. Okay, so remember, this is just a rough sketch. So this is now C. Now that you have been given C, B, they're telling you that there's a bearing of 140, and BC, they tell you that this distance here also is 20 kilometers apart from each other. So that's the next key point. That's 20 kilometers. Okay, so remember that this is 140, so write that down, degrees. Okay, and now they say sketch a diagram. The mere fact they told you sketch a diagram, it means that you would be needing the diagram to assist you. So sketch a diagram showing the direction, location of all the points. So it is A, B, C. Mention also show clearly the north of all at all times in your working. So that's north, and B would have north here also, and C would have here north. Okay, that would be the first part of the problem. Okay, doesn't bear any grade, but you go now. Yes, it does bear a grade, so you finish with that piece there. So now what we are going to do is to solve the problem from what you have been given. So we look at the problem here, and we see what you are being asked. You are being asked to calculate the distance or length AC. What is this length here? Okay. Now, having drawn a rough diagram on the bearing, now you could bring out the diagram and put it to the side and see what is it that you have. Okay. So let's draw the triangle here. So we concentrate on the triangle. So more or less, this is how the triangle would look. You have here A, B, C. You know that this is 10 kilometers, this is 20 kilometers. You know that because this angle here is 140, notice that this is a straight line. This is 140, but this angle here in between is 30 degrees. Notice the words that I'm using. The angle here is 30 degrees. The angle here is 140. For our purpose here, we are working now with degrees. Okay. So when you speak of degrees now, if this is 30, then this angle here will be equal 140 take away 30 degrees. So we put here now that angle CAN or NAC equals the addition of angle CAB plus angle BAN. Okay. Okay, so we are there now. So we substitute whatever we have so we can get this angle BAC. So this is what we need, BAC or CAB. CAN is equals to 140, which is equals then CAB, angle CAB plus BAN, which is 30. So angle CAB is equals 140 take away 30, which is 110 degrees. Okay, again, this was just a rough sketch, right? So remember, it's just a diagram. So this is telling me that this angle here is 110. So I could put here now 110 degrees. Okay, now having done that, now it says calculate the distance AC. This is the length that I want. So can we figure out that length? Well, at this time we should be able to figure it out, but we need at least one more piece to this diagram. Okay, we need this internal angle. We can use sine. No, yes, we could use sine here by getting this angle on this side, and then this side and this angle, and then that will give us to find this angle C, and then add the 2 and subtract from 180 to get this higher angle, and then find this by using cosine. But since you notice that you are being asked for a lot of bearings, my advice is that you try solve what are these angles here in between. Okay, so if I was to extend this line here, you are going to notice that this angle 30 is also equal here. Why? Because this angle and this angle are alternating angles. These two lines are parallel lines. This is a transversal. So we can put here 30 degrees. Now, the same way how we had here of 140, we could work with this other piece here. Likewise, if we knew the angle of C from B. Okay, so we don't know that at this point, so we cannot go any further from there. So what we do here then is that you see, notice what you have gotten, and you can't go any further, so you go the other route. This route would have been easier if we knew the angle BMNBC, so with this open angle here. So let's find this angle C. By finding this angle, we will add this angle plus this and subtract it from 180 to get this other angle. After you have gotten this angle, you can use this angle and these two sides to find the third side. Okay, so that you can find using the cosine rule or sine rule, whichever one you want to use. So let's find this angle. And why are we going to find this angle? Because if we find this angle, we can get this angle, and then from this angle we go to this other side, which will be calculate the distance AC. So we put now here 20 kilometers over sine of 110 degrees equals then 10 kilometers over the sine of C, which we don't know. Okay, cross multiply and you end up with sine C is equals to 10. Disregard the K and the Km so it doesn't cause confusion. You get that over 20 kilometers. This will now give me that the arc sine of 10 sin 110 degrees over 20 will equal to the angle. Alright, so we do that, we just do the rearranging, which is in algebra. So you take your calculator there and you start. Arc sine means shift sine bracket bracket, because I'm going to do one operation, two operation, and then close it. So the first part of the operation says 10 times sin 110 degrees divided by 20, close it, equals 28.0 degrees. For our purpose for this exercise, we will be using lone whole numbers. All right, so we put here 28 degrees, two significant figures. Okay, so now we take this angle and put it here, which is 28. And now if you notice, we have two angles within a triangle, and if you have two angles within a triangle, you could figure out what's the third angle by adding two angles and subtracting it from 180. So we say total angles in a triangle equals 180 degrees. So we put 180 equals 110 plus 28 plus, let's call that angle B. So angle B is equals to 180 take away 110 plus 28 open close bracket. Angle B then is equals to 180 take away 110 and 28, and that gives us 42 degrees. Remember, this dictates what will be our value, if it will be decimal or whole numbers, but for right now we're going to be using lone whole numbers. Okay, so we take our value and put here 42 degrees. All right, so that is how we have labeled that. Now what we want is a distance AC, this length here now. So we could now use sine rule or cos rule. Let's use sine rule, it's much simpler. So therefore you put AC over the sin of 42 is equals to, and you could choose any other side. Let's put 20 over sin 110. AC is equals to 20 sin 42 over sin 110, and that will give us our solution. So we take 20 times sin 42 equals divided by sin 110, and that gives us a length of 14 point something. Let's call it to a whole number, which is 14. So this is 14 to two significant figures. Okay, so we have gotten that now. So we have solved now for the length AC, or the distance of A to C or C to A. Now we are to calculate the bearing of A from B. What is that? Well, let's see. If I want the bearing, so remember we have solved the first one, which is 14 kilometers. Now here, because you have finished at the end of the problem, here make sure you put your unit 14 kilometers. That will lose you some points if you don't include it. So let's go back to the problem. calculate the bearing of A from B. So I want the bearing of A from B. Okay, so if you notice here, this angle is 42, which is comprised of the whole of this. Okay, so what can you do? Well, if I want the bearing of A from B, then what am I looking for? I'm actually looking for this angle. Okay, at first we did not know what would have been this angle, but now we know what it can be. But what we want is this angle here, which will be the angle of A from B. And how do we get that? Well, this is 30 and this is a straight line, so we can put bearing of A from B is 30. I'll put 30 degrees plus 180, that gives us 0, 210 degrees. So that's the bearing of A from B. Notice how that's a straight line, that's 30, so we got the bearing of A from B. Now let's go to our next one. Calculate the bearing of C from B. What is the bearing of this angle from this angle? In other words, they're asking you for this small angle. Okay, knowing that this angle here is 42 degrees, that 42 degrees has 30 already included, so the difference will be right here. So you put that this angle, you can put it, you could call it any angle you want it to be called. And let's say you now say that 42 degrees is equal to the 30 plus, let's call it a label of an x. So we solve for that x and we end up with 42, take away 30, which is 12 degrees. So this angle here is 12 degrees, but that's not what we want. What we want is this angle. But if this is 12 degrees and this is part of a straight line, then we can say that angle NBC, which is the bearing of C from B, for C from B for this one here, which is D. So remember, this was A, and this was B, this was bearing, this was C, and the bearing, and this is D. So now we're going there, so we get 12 degrees, and so we say 180 take away 12 degrees, that will give us 168. 168 is the bearing of C from B. So bearing of C from B. Notice why. We got the 12 degrees, which is right here, and so we subtract the 12 from 180 to get this angle which C has from B, which is the bearing of C from B. So we've finished with this one here. Now we're going to E. What is the bearing now of B from C? I want to know what is this bearing. Okay, now the way you're going to solve that is very straightforward. If you look at it from parallel lines with a transversal, this is 12 degrees here, these are parallel line, these are parallel line. That's why you were told to make sure you label it properly, nerd. So if this is 12, then this must be 12. This is angles at a point, so if I subtract 12, then obviously I get this angle outside. Okay, so for E, I'm going to say angles at a point gives me this 12 degrees, and so I say 360 degrees minus 12 degrees is going to give me 348 degrees. Okay, so 348 is the bearing of B from C, bearing of B from C. So we finish with that bearing now. And now the next bearing says calculate the bearing of A from C. What is this bearing here when you look at C this way? So this is now the angle that we want. We want to know that angle. Okay, what do we have? We know this is 12 here. We know that this angle here is 28. So if I take 28 plus 12, I can subtract that from 360 to get the bearing of A from C. So for F, I'm going to say 28 plus 12, and that's going to give me 40 degrees. Okay, so we get 360 minus 40 degrees, that gives me 320 degrees, which is bearing of A from C. And we're done with our problem there. So notice how you went through with this problem. Depending on how you want to approach it, you get your problem done. But all you're doing is just looking at it. But you must be careful with this word, from what to what. Okay, so that is where the challenge will come in. This is English language part, so that requires understanding. Okay, so this is one of them.